Hi students, today we are going to start a new chapter, electricity. Electricity has an important place in modern society. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals and so on. What constitutes electricity? How does it flow in an electric circuit? What are the factors that control or regulate the current through an electric circuit? In this chapter, we shall attempt to answer such questions. We shall also discuss the heating effect of electric current and its applications. First, we are going to study about electric current. Before that, we should know about conductors. We know that conductors which conduct electricity. In depth, an atom consists of positive nucleus surrounded by negatively charged electrons. In certain substances, the electrons in the outermost shell are loosely bound to the positive nucleus, and hence these electrons can be easily removed from them. These electrons are called free electrons. In some other substances, the electrons are strongly bound to the positive nucleus. In such cases, it is difficult to remove these electrons. Here there is no free electrons. Note the point. The substances having free electrons allow the electric current to pass through them. Such substances are called conductors. Metals are the good conductors of electricity. Silver is the best, and gold, copper, aluminum are the examples of these type. Okay, don't get confused. Then the substances which there are no free electrons and do not allow the electric current to pass through them are called insulators. Non-metals and paper, wood are the examples of this type. Okay, so we are moving on to the portion electric current. Electric current is the flow of electrons through a conductor. Simply, it is a flow of electrons through a conductor. But there is a second definition. It is the rate of flow of electric charge, or the electric current is the quantity of charge flowing per unit time. Note the point. The electric current is the quantity of charge flowing per unit time. Okay. If a charge Q flows through a conductor in a time t, then current I flowing through the conductor, then I is equal to Q by T. So I repeat the definition. It is the rate of flow of electric charge. Then I is the current and Q is the charge and T is the time. Okay. The unit of current is ampere. The SI unit of current is ampere. Okay. By the definition, 1 ampere is equal to 1 coulomb per 1 second. I'll repeat. 1 ampere is equal to 1 coulomb per 1 second. Okay. The 1 ampere is the current flowing through a conductor if 1 coulomb charge flows through it in 1 second. The definition of 1 ampere. The 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. Okay. Then the electric current is measured by ammeter. A meter is a device. Okay, it is always connected in series in a circuit. Look at the picture. The picture shows it is a schematic diagram of a typical electric circuit comprising of a cell and a resistor. Note that electric current flows in the circuit from the positive terminal of the cell to the negative terminal through the bulb. So, the students, note the point. The device which causes flow of charges or flow of electrons is called a cell. Okay. Then the electric current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell. This current is called conventional current. This current is called a conventional current. Then the electrons flows from negative terminal to positive terminal. We know that electron has negative charge. Okay, the electron flows from negative terminal to positive terminal. Okay, then the direction of current, not the point, the direction of current conventionally, the direction of current flow is taken to be in the direction of positive charge. The electrons flow in a direction opposite to the conventional current. Okay, clear? Then we are moving to the next topic, electric potential and potential difference. Okay, listen here. What makes the electric charge to flow? Let us consider the analogy of water, flow of water. Okay, charges do not flow in a copper wire by themselves. Just as water in a perfectly horizontal tube does not flow. If one end of the tube is connected to a tank of water kept at a higher level such that there is a pressure difference between the two ends of the tube. Okay, water flows out to the other end of the tube. For flow of charges in a conducting metallic wire, the gravity of course has no role to play. The electrons move only if there is a difference of electric pressure called the potential difference along the conductor. This difference of potential may be produced by a battery. So battery is a combination of two or more cells. I repeat, the battery is a combination of two or more cells. Okay, come to the point. This difference in potential may be produced by a battery consisting of one or more electric cells. Okay. The chemical action The chemical action within a cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charge in motion in the conductor and produces an electric current. Okay, note the point. When the cell is connected to a conducting circuit element, the potential difference sets the charge in motion in the conductor and produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expend its chemical energy stored in it. Okay, so we defined electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. So note the point. We define electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. The work done to move a unit charge from one point to another. Okay, the potential difference between 2 points is equal to work done divided by charge. Work done divided by charge. Okay, look at the slide. The electric current will flow through a conductor only if there is a difference between the electric potential between the two ends of the conductor. This difference in potential between the two ends of a conductor is called the potential difference. The potential difference in a circuit is provided by a cell or battery. Okay. The chemical reaction in the cell produces a potential difference between the two terminals and sets the electrons in motion and produces electric current. Okay, so the point potential difference, note the point potential difference is the between 2 points A and B of a conductor or two ends of a conductor. Conductor is the amount of work done to move a unit charge from A to B. Then potential difference is equal to work done per charge, or V is equal to W by Q. Then the SI unit of potential difference is volt. So we can define 1 volt. Okay, 1 volt is equal to 1 joule per 1 coulomb. We have learned before 1 ampere is equal to 1 volt by 1 ohm. So similarly, here 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to another. Don't get confused. 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to another. Okay, that is 1 volt is equal to 1 joule per 1 coulomb. Okay, then note one point. Potential difference is measured by a voltmeter. Potential difference is measured by a voltmeter. Earlier we said current is measured by ammeter. The current is measured by ammeter and the potential difference is measured by voltmeter. Note these 2 points. Okay, it is always connected in parallel. So note the point. Ammeter is always connected in series and voltmeter is always connected in parallel. Okay. So we are going to the next topic, electric circuit. Then listen here. Electric lamps, heaters, air conditioners, motors, and various other devices which work on electricity are called loads. LOADS loads, because these consumes electric energy. In order that electricity flows through a load, it has to be connected to a source of electric power. Example, a battery or a generator through wires. Okay, then the electric circuit, a source of electric power, a battery or an AC source, loads, switches, and other elements connected together by wires forms an electric circuit. A drawing showing the way of electric devices are connected in a circuit is called a circuit diagram or a schematic diagram. Okay, the point I repeat, electric circuit is a continuous and closed path of an electric current. The another definition is a source of electric power, loads and switches and other elements connected together by wires form an electric circuit. So okay, then look at the picture. A schematic diagram of an electric circuit comprising of a cell, electric bulb, ammeter, and a plug key. This is cell. This is an electric bulb. This is an ammeter. This is a plug key. Look at the picture. These are certain symbols are used to represent various devices. Okay. The first one, The first one, the connecting wire. Connecting wire. Note the point. A connecting wire is usually made of copper covered with cotton or plastic insulation. Note the point. A connecting wire is usually made of copper covered with cotton or plastic insulation. The resistance of a connecting wire is negligible and is taken as 0. Okay, note the point. Resistance is the opposition to the current flow. Resistance is opposition to the current flow. Okay, then the second one, the second diagram, a rheostat. Okay, rheostat. This is a resistance box. Okay, the resistors, rheostat, resistance box. The rheostat and resistance box consist of wires which are generally made of alloys such as manganese and constantan. Note the point, manganese and constantan. Whereas a resistor provides a constant resistance in an electric circuit. We have studied earlier, resistance is is to resist the flow of current in an electric circuit. Okay. The rheostat and resistance boxes consist of wires which are generally made of alloys such as manganese and constantan. Okay. A rheostat and a resistance box are used to change resistance in an electric circuit. Okay, clear? A rheostat and a resistance box are used to change resistance in an electric circuit. A rheostat acts like an unknown variable resistance. Underline the point. A rheostat acts like an unknown variable resistance, and a resistance box provides non-variable resistance. Don't get confused. A rheostat acts like an unknown variable resistance, and a resistance box provides non-variable resistance. Okay. Then, and this is galvanometer. The galvanometer used for detecting the flow of current in an electric circuit. It has two terminals, positive and negative. So galvanometer is a device used for detecting the flow of current in an electric circuit. Okay. Okay, this is electric bell and this is electric bulb and this is a battery. A group of cell constitutes a battery. Okay. So we are moving to the next slide. Then the first figure is a wire crossing without connection, because these are not connected. These wires are not connected. Okay, the second figure is a resistor, a typical resistor. Okay, and the third figure is a variable resistor, and this is a plug key. Then this condition is plug key is open, which means the circuit is off. This picture, the plug key is on or the closed circuit. This is a tapping key. This is a voltmeter. We studied earlier voltmeter, which is used to measure the potential difference. Okay, this is a meter. The meter used to determine the current in a circuit. So we are moving on to the next slide. The next topic is Ohm's law. We have already seen that flow of a liquid depends on the pressure difference. We have studied earlier in the potential difference. Okay. Similarly, the flow of electric charge through a conductor depends on the potential difference across its ends. Okay. The scientist George Simon Ohm. The scientist George Simon Ohm was the first to make quantitative study of this phenomenon. Okay. Then Ohm's law. If physical conditions like temperature of a conductor are kept unchanged, the strength of a current flowing through it is directly proportional to the potential difference across its ends. Note the point. If physical conditions like temperature, etc., of a conductor are kept unchanged, the strength of a current flowing through it is directly proportional to the potential difference across its ends. Okay. This statement is known as Ohm's law. Okay, very, very important statement. Then V is taken as potential difference applied across the ends, and I is the strength of current. Then I proportional to V, or V proportional to I, or V by I is a constant, or that constant R is called, that constant can be taken as R. The constant R is called resistance of the conductor. Okay, I repeat, the current flowing through a conductor is directly proportional to the potential difference between its ends, provided its temperature remains constant. Okay, the physical conditions remains constant. Then I proportional to V, or V proportional to I, or V by I is a constant. That constant is called resistance of the conductor. Okay, resistance is the resistance, simply called electric resistance. Okay, the resistance is the property of a conductor to resist the flow of charges through it, or it is going to resist the flow of current. Okay, the unit of resistance is ohm. Next, the verification of Ohm's law. Listen to the circuit diagram. There are following components. First one is the battery. This is the battery. A battery which is used to send current in the circuit. The second one is a rheostat. A rheostat, which is a variable resistance, and it is used to change and adjust the current in the circuit. A resistance wire AB of fixed resistance R. Okay. An ammeter which is used to measure the current in the circuit. I repeat the components. First one is the battery, second one is a rheostat, and third one is a resistance wire AB, and the fourth one is the ammeter, and the fifth one is the voltmeter. Voltmeter, we know that voltmeter is used to measure the potential difference across the circuit. Okay. Listen here. The procedure. Set up the circuit as shown in the circuit diagram. First, use one cell and note the current I in the ammeter and the potential difference V in the voltmeter across the nichrome wire AB. Repeat by using 2 cells, 3 cells and 4 cells, and note the readings in the ammeter and voltmeter. Okay. Then plot a graph between the current I and potential difference V. The graph will be a straight line. This shows that the current flowing through a conductor is directly proportional to the potential difference across its ends. Okay, look at the diagram, look at the graph. Okay, V proportional to I. Okay, I repeat in depth. Okay, the following components are a battery, and a rheostat, and a resistance wire, and an ammeter. Okay, then when the key is closed, means the key is on, a current starts flowing in the circuit. Okay, simply when the key is closed, so we can short the points. When the key is closed, a current starts flowing in the circuit. The current in the circuit is changed by adjusting the rheostat, and the readings of voltmeter and ammeter are taken. These readings gives us the value of potential difference across resistance R and the current flowing through it. Okay. This verifies the Ohm's law. Thank you.